Welcome to the lecture series on tricks of the trade in deep learning with artificial neural networks. This video covers data augmentation. Data augmentation is a method of regularization, and it works like this. You start with a database of P data points. Let's say the data points are images. Now, for each image, you create new images that should reflect the invariances of the task. For example, a butterfly remains a butterfly if it's flipped. It remains a butterfly if it's randomly translated, for example here, diagonally translated. It remains a butterfly if there's a change in the color scheme. It also remains a butterfly if there are some transformations that change the shape just a little bit, elastically or an affine transformation, and if there's noise in the image, it's also a butterfly. So out of a single butterfly image with the label butterfly, we can easily generate 10, 20, 30 additional images for which you can just use the same label. This procedure is called data augmentation or dataset of augmentation. But there are also other ways to perform dataset augmentation on images. For example, we can exploit the fact that humans recognize objects and scenes not just from photos but also from artistic paintings. For example, we have no problem to recognize here a boathouse and a boat in a country setting. Or if you look at this, yes, this is the face of a man. He probably thinks about something or he has drunk too much beer. What's this? Well, this is the sky in the night. All of these are highly stylized images. With AI methods, stylized versions of images can automatically be generated. So here are originally photographs, and here are the different styles. So I did my undergrad studies in Tübingen. This is an image of Tübingen, and this is Tübingen in different styles. Well, this is the Golden Gate Bridge in different styles. This is a farmhouse in the country in different styles. So for each original image, you can easily and automatically generate with modern algorithms copies of the image in different styles. Many deep neural networks have been trained on a large dataset of images that's called ImageNet. If you train a standard neural network on these images, you find that the deep network does amazingly well, but it's very brittle. Even small changes in the image lead to a breakdown of the recognition. So we said that humans are able to recognize objects not just from clear images, but also from stylized images. And we have algorithmic methods to start from an original image and generate stylized images in many, many different styles. Maybe 100 different styles, maybe 500 different styles. So humans are able to recognize these images. This is still a panda bear, but then machines should also be able to recognize these images. And what we can do now is that we do database augmentation for the relatively easy original images. In fact, for all the images, we generate new images in various different styles. And if you do that, it turns out that a deep network that's trained with this augmented database of images is much more stable, less brittle, and it's also much closer to the way humans recognize different images. To summarize, we may say that dataset augmentation is a regularization method because it avoids overfitting. You do dataset augmentation by generating new data, and this new data should reflect the known invariances of the task. it's not very costly to generate this extra data because algorithms can do that. And you don't need a human labeling the image. In fact, the labels for the augmented images are just copied from the originals. And of course, the standard example is the example of images, but dataset augmentation also works for other types of input vectors. And in all cases, you want to be these extra input vectors, you want them to be generated automatically by algorithms. And then you end up with an augmented dataset, and the trained network will perform much better than the network only trained on the original input vectors.